If I look currently at our market for HPC, the demand is basically driven by two factors. The uninterrupted demand for higher number of flops, higher demand of computing power that is required by our customers. And we don't see a real stop into that demand. Actually, it is very nice to work for HPC because it is one of the very seldom growing sectors that we currently are serving. And this is very good news for all of us. There's also one important point. It is the fact that demand is driven by the governmental and European Union initiatives, which are providing at the same time many opportunities for us to develop competitive offerings and provide innovation that our customers need to have to make sure that the workforce is able to stay competitive on that world market. So the demand is driven from that angle. Another angle that we see is the fact that we have a growing demand coming from the what I call non-academic or industry customers, which at the same time are leading the demand in terms of new requests, basically driven by data-focused opportunities. So this is where we see the biggest type of demand currently. If I look at the way that we serve at our customers, we still have a very large number of customers which are using very what I call traditional computer-focused equipment. And this is something that is more or less staying quiet, staying at the same level. We do not see a lot of growth. However, many of our customers are now moving into a much more different model, which is what I would call a service-led model. So what do I mean by that? It is basically a statement from customers which are telling us, hey, I'm running my own business. I'm not someone that wants to run IT systems. It is not my job. So I would like to work with HP to make sure that you provide me the full system and the full capabilities that I require. And at the same time, I do not want to be bothered by anything else but having SLAs, service level agreements with HP, and you take care of everything. I just have my engineers to use the resources that you provide to me. And this is something that, especially in the manufacturing, automotive, aerospace, banking, we now see appearing much more than in the past. This year, we are very happy to say that we have regained our top 500 number one position. So in the last publication that was done in November 2013, HP is now coming up at close to 40% of the top 500 in terms of number of systems installed, which is close to 200 systems installed worldwide. That shows you one thing. It shows you that at HP we pride ourselves on being able to integrate, deliver, and safely have our systems installed at our customer sites. We have numerous branches of HP which work at integrating our systems, checking them at factory level, making sure that the software is properly installed, and that for only one reason. It is the fact that we want our systems, when they arrive at our customers, to be fully operational. And this is something that we are very proud of. Moonshot, for the time being, is considered by our customers as a kind of side offering for our HPC customers. The reason for that is that, as we told you, Moonshot is a software-driven architecture. So that means that the cartridges that we are developing are developed for a specific type of workload or for a specific type of application. And for the time being, our roadmap is still not yet there for the type of workloads that our HPC customer require in terms of floating point operations or precision, double precision calculations. So this means that for the time being, we use Moonshot for quite a number of what we call side topics beside HPC. And in our roadmap, we do have HPC dedicated cartridges that are now going to come up. So just bear with us, and it will be a matter of a few months until we have HPC offerings on our Moonshot platform. Typical examples of usage are where customers do have a very specific type of software solution that would require something that could fit on an existing cartridge that is available. So things like login nodes, session management, things like very specific genome applications which do not require double precision. So we do have quite a number of those smaller sectors for the time being, which are able to take advantage of Moonshot. But again, for the time being, we still consider that as a side topic, and the main part of that Moonshot HPC offering will come a little bit later in the year. Now a few words about the pod or performance optimized data center offering that HP is providing. In quite a number of cases, we do have customers which are not able anymore to handle the evolution of their data center. A data center requires usually 2 to 3 years of studies and building the data center itself. And whenever you get to the point where the data center is built and operational, you suddenly realize that technologies have changed and that the data center by design was not properly set. So we have cases of these customers which today tell us, I would rather look at having a containerized offering. So this container would enclose my entire IT. And in the life cycle of that IT system, the data center is part of it. So that means that some customers, they are simply buying from us the entire IT, including the data center, including the cooling, including all the facilities that go with there and that goes with that. And they properly integrate that and include that into a global ROI. After the end of the lifetime of this system, they simply get rid of everything. They put everything away and they replace it by a new system. So this is a typical example that we highlighted yesterday during the presentation with Airbus. Airbus is telling us, I do not want to bother about my IT, please provide me everything. So we provided our solution within pods, and the pods, after the end of the lifetime of the product, have been replaced by new pods. And this is a very simplistic way of handling the ROI of a data center, reducing the initial investment and being able to put all that costs on a real OPEX. So we now have a very nice reference that was announced by the National Renewable Energy Labs in the US. So this lab, as you may imagine, is extremely sensitive to power efficiency, to cooling efficiencies. And we have been able to develop with them the system that they just implemented, and it is a 1.2 petaflop system. It is warm water cooled, and we have implemented that in the context of a study that was basically willing to demonstrate that energy efficiencies are pushed to their maximum. So we have reached a power usage efficiency on this system of 1.06, which is pretty nice these days. And we even are going lower in a sense that we are recycling the warm water that is coming out of the systems, and which is being resent to the rest of the campus, either to cool buildings, to cool or to heat buildings, depending on how you use that, or to melt snow during winter. So this is the type of energy efficiencies that all of us are looking at. And in this respect, this prototype that we have implemented that will be normally giving announcements later on during the year for a future product coming from HP.